Okay, in this video I want to go over another example of transformation of function with the function sine of x. So as usual, using the order of operation, we are going to go one transformation at a time in the same order. So we have parentheses denoted by capital P. Now instead of parentheses, we are going to have horizontal translation either to the left or right by a certain amount of units. Well, we are translating pi over 2 units to the left. So we get x plus pi over 2. But now also still inside a parentheses, or more specifically speaking, inside an outer parentheses, we are going to have to multiply this whole x expression by the minus sign because we are also reflecting across the y-axis or horizontally reflecting across the y-axis. So that's why we need to have another pair of parentheses. So capital P is done. Exponent, we don't have any. Multiplication, well, in addition to the one that we multiply in here by the negative side, we also have to multiply this whole sine function, I should say, by a factor of 1/2 because we are vertically compressing the function by a factor of 1/2. So this is 1 over 2, like that. And we get this out of the way. Okay. So this is done, this is done, and this is done. So the last transformation is translating upward by 2 units, and that is going to be represented by addition now, since we don't have any division and we also don't have a subtraction. So addition is the last one. And so we basically just take this whole thing and we add 2 to it. So the function that represents all of these transformations is f of x equals the product of 1/2 and sine of negative of x plus pi over 2, and then all of it plus 2. So how do we graph this? Well, we always want to start graphing with, hold on, hopefully you can see it here. We always want to start graphing with the parent function, sine of x. So plug and chug. If x is 0, sine of 0 is 0. When x is pi over 4, sine of pi over 4 is positive square root of 2 over 2. So maybe somewhere right here, I would say. When x is pi over 2, sine of pi over 2 is 1. So like that. When x is 3 pi over 4, sine of 3 pi over 4 is positive square root of 2 over 2. When x is pi, sine of pi is 0. When x is 5 pi over 4, sine of 5 pi over 4 is negative square root of 2 over 2. So maybe right here. When x is 3 pi over 2, sine of 3 pi over 2 is negative 1. So right there. Yep, let's make a big one. When x is 7 pi over 4, sine of 7 pi over 4 is negative square root of 2 over 2. When x is 2 pi, sine of 2 pi is 0. So connecting this set of points, we are going to get part of the graph of the parent function. So of course, one cycle with the value of 2 pi, the graph of sine is going to look like this. For the next cycle from 2 pi to 4 pi, it's just going to be another copy of this, paste it over here. Now, to go the opposite direction, it's almost like we take these points and we just go the opposite way. So, of course, if you go up this way, you're going to go down this way. So if this point is here, the opposite copy of it is going to be over here. And that is true because when x is negative pi over 4, sine of negative pi over 4 is negative square root of 2 over 2. When x is negative pi over 2, sine of negative pi over 2 is negative 1. When x is negative 3 pi over 4, sine of negative 3 pi over 4 is negative square root of 2 over 2. When x is negative pi, sine of negative pi is 0. When x is negative 5 pi over 4, sine of negative 5 pi over 4 is positive square root of 2 over 2. So right there. When x is negative 3 pi over 2, sine of negative 3 pi over 2 is positive 1. So right there, I'm just going to eyeball it. When x is negative 7 pi over 4, sine of negative 7 pi over 4 is positive square root of 2 over 2. That. When x is negative 2 pi, sine of negative 2 pi is 0. So we connect all of these points again. not again, but we are connecting these points to go the opposite direction of the graph of sine of x. Like that. Right? So this graph here is called sine of x. Now, in front of the sine function, there's actually the invisible multiplication of the invisible positive 1. So the number on the front here is called the amplitude of the function. So the amplitude of the sine function is positive 1, and the amplitude is just half of the distance between the highest y value, which is positive 1, and the lowest y value, which is negative 1. So it's this half we're talking about, or this half. So like that. Okay. So let's graph the first transformation, which is left translation by pi over 2 units. To do that, we take the most recent graph, which is this one right here. We shift the entire graph pi over 2 units to the left. So if I were to take every point I plotted here and I shift each of them pi over 2 units to the left, so this one would end up right here. And then so it's 1, 2 like that. The next one would be 1, 2, end up right here. Next one will be 1, 2. This one as well. And you keep going. So you plot the first half. You sketch the first half of the left translation by pi over 2 units graph. Now for the second half, same thing. Well, we started from here, right? So we started with this pi over 2 units to the left. So 1, 2. This one end up right here. This one, 1, 2, end up right here. Yeah, this one, 1, 2. This one, 1, 2. 1, 1, 2. This one, 1, 2. Oops, wait, that's pretty bad. And this one, 1, 2. So yeah, I'm just gonna eyeball it. And it's difficult to graph it on a blank sheet of paper because there's no line to try to make your graph as exact as possible. But this is kind of a rough sketch of it. Yeah, right. So yeah, the one in the blue right here is the graph of sine of x plus pi over 2. Right, so hopefully I can see that. Now the next transformation is the horizontal reflection about the x-axis. So the way I think of that is I just take the most recent graph, which is the one in the blue, and for example, let's just say I take this part, and when I reflect them horizontally, it seems like this point end up over here and this point end up over here. Okay, and when this point end up over here and this point end up over here, it seems like it's almost the same as saying that there's a vertical mirror image of this point being up here and a mirror image of this point being down here. So that's my understanding of horizontal reflection. Okay, and of course the same thinking apply for every other part of the blue graph here. So let's say flip it like that. This one end up right here, and this one end up right here. Okay, and of course, for this part here, if we reflect them horizontally, if we reflect them horizontally, the arrow would actually end up down here. Okay, and the fun fact is that when we do horizontal reflection from the blue graph here, every point on the x-axis of the blue graph is going to be the point of intersection between the blue graph and the one in the green that I'll be drawing in a bit. So that's why on the green graph, this point is going to be here and this point is going to be there. It's going to be, this one is going to be on the green graph as well. This one will be on the green graph as well, all right? And of course, for, you know, for this highest point, when we reflect them horizontally, you know, it's going to end up, this one's going to end up over here. And this one going to end up over here, so we got that, okay? And of course, this one, if we flip them horizontally, you know, this one end up over here. Of course, this one end up over there, okay? So that's just my understanding of it. So we just connect them. So we connect from here, go through the point on the x-axis of the blue graph, and we just keep going, okay? And of course, this, again, this is the rough sketch, so it may not be as exact, oops, like that. And you got that up here, down, and yeah, just like that, okay? So yeah, that's how I graph it. So the one in the green is sine of negative of x plus pi over 2. Now the next transformation that I'll be graphing from the most recent graph in green is the transformation of vertical compression by the factor of 1/2. And the way we do that is that we take the most recent graph in the green and we just press everything down by 1/2. So let's say for this point, we would press it up to here. For this point, we will press it down to where 1/2 is, so somewhere right here. And for this point, same thing, press it down by 1/2. This point would be pressed up by 1/2. And we just connect the point in the red. And of course, like usual, the point on the x-axis of the green graph is going to be the point of intersection. So that's my understanding. And of course, right here, point on the x-axis of the green graph, it's going to intersect right there. And it's going to keep going like that. And we just connect the other half. Go through the point of intersection, which is the point on the x-axis of the green graph. So right there. Keep going. Same thing right here, and we keep going like that. So it's a bad graph. My apology. So the one in the red right here is the 1/2 times sine of negative of x plus pi over 2. Okay. Now lastly is the transformation of going upward by 2 units. And of course, in a similar fashion, we basically just take the most recent graph, which is the one in the red, and we move the entire graph up by 2 units. So let's take the point that we just plot on the red graph. Let's start with this one. We move it up by 2 units, so we go from negative 1/2 to 1/2, that's 1 point. From 1/2 to 3/2, that's where it's going to end up for the last transformation. Same thing for this point. It's at 1/2, so we move to 3/2, that's once. We move to 5/2, that's twice. So this is right here is 5 over 2. Okay. And same thing right here. It's at 1/2. Moving to 3/2, that's once. Moving to 5/2, that's 2. And same thing right here. From negative 1/2 to 1/2, that's once. From 1/2 to 3/2, that's twice. So just gonna eyeball it. And yeah, we're just gonna keep, we're just gonna make a copy of the red graph, but now it is gonna be in the purple. Right? And this one will keep going like that. So the one here, this graph right here in the purple, is basically this function right there. And yeah, that's how we graph each transformation of this sine function. Hopefully you guys can see that. Okay.